Today is day 3 of Unit 4. We're going to answer the question, how do we model exponential functions? So if you think back, first we're going to talk about with a table, writing an exponential function from a table. So remember, our equation is f of x is equal to a b raised to the x power. So a is our initial amount. We're going to start out with a being equal, x will be equal to 0. Okay. B is going to be equal to the common ratio. And I'll talk more about the common ratio later on in the unit, or in the lesson rather. And x is the exponent. So we're going to be talking about this again in function notation, so f of x. So when I say that x is equal to 0, I'm saying f of x. Okay, I'm talking about so when this is equal to 0. Okay? So the initial amount in example 1 would be right here, okay, because x is equal to 0. Again, remember a is our y-intercept. Just to review, this is our y-intercept. Okay, so this is going to be our a value right here. Okay, 2 will be our a value. So the next thing we're going to do is, just as we did when we were talking about linear functions, is we're going to look for the patterns. This is the nice thing about having our points in a table, our coordinates in a table, is that we can look and see what is happening as we go up or as our coordinates go down. Okay, so with our linear equations, remember that we were looking for if we could add the same to go up. Now I know, okay, 2 plus 4 would get me 6. 6 plus 12 would equal 18. So we know this isn't linear, okay? So let's try and find another pattern that we can find. Well, I know that 2 times 3 is equal to 6. 6 times 3 is also equal to 18. And 18 times 3 is also 54. Okay, so what this is our common ratio. This is our common ratio. This is what we're trying to look for. Okay, so to finish this off, now that we found our common ratio, which is our b value.
Dan Clemens, if you're in the building, could you contact the main office? Dan Clemens, if you're in the building, could you contact the main office? Thank you.
Sorry for the interruption. So, for our final answer, for our, sorry, we're doing function notation. So for our final exponential function, we're going to write f of x is equal to 2, because that's our a, times 3 raised to the x power. Simple as that. Okay? So let's try some examples. All right, now for example number 1, this one, the table is going the opposite way, so you have to make sure that you look where the x and the y is. So again, our x, that's just going up by 1 each time. And then our y, now be careful when we're doing the negatives, okay? These are also going up, so these are times 3 each time. Okay, so again, same thing. So a is equal, let's see, so remember, this is our a value right here, okay? So a is equal to -1, and b is our common ratio, is equal to 3. Okay? So our function, remember it says function, okay? Function rule, it's just the way that we describe it. Okay, so f of x is equal to -1 times 3 raised to the x power. Okay, the next thing it wants us to do is it wants us to evaluate. So if x is equal to 6, what will our y be? So remember the way we do this, we did this the other day. You're just going to substitute that in. Okay, so go ahead and put 3 raised to the 6 power in your calculator. You'll get 700, let's see, 729. Yep. Okay.
Donna Wilkes, if you're in the building, could you come to the main office? Donna, to the main office, please.
There you go. Okay, so your final answer is negative 729. Not too complicated. Okay, let's keep going. All right, so now we have, let's see, the first thing I want to do is I want to identify my a value. So remember, our a value is just our y-intercept. Okay, so a is equal to 1. Remember, just a reminder, our y-intercept is when x is equal to 0. Okay, the other thing I want you to make sure you look at is make sure, usually we can disregard the x's when we're finding our common ratio, but just make sure that they're going up by 1 each time, just because it does change your answer, and you might have to find a couple different of the in-between numbers, but we'll talk about that in a second. Okay, so let's see. So here, now I see that my numbers are going down. Well, the important thing is the common ratio is always multiplication. So you might be saying, okay, but my numbers are going down. So how is that possible? Well, if your numbers are going down, then you have to divide, right? Well, we're not actually going to divide, okay? So I see that these are being cut in half, right? So they are being divided by 2. Well, that's the same thing as multiplying by a half, okay? So I see that every time they're being multiplied by a half, a half, a half, a half. Okay, so my common ratio is a half, so b is equal to 1/2. Don't forget to write your equation. So f of x is equal to 1 times 1/2 raised to the x. Okay, technically you don't need that 1, but we are just learning, so I want to make sure that you guys understand that the a value right here represents the y-intercept, and this is what you would graph first. That would be the easiest to graph first. All right, number 3. Okay, so my recommendation for this one would be to plug these into your calculator and see which one matches. Now, the first thing I noticed, okay, so we are looking for an exponential function, okay? Because as these, so this goes up, this is plus 1, plus 2, plus 1, plus 1. Okay, these are clearly not going up by the same amount by adding, so it's got to be multiplication or a mixture of both. So the first thing I'm going to do is I'm going to cross off 2 and 4 because they're linear. Okay? The reason they're linear is because they have, well, they're in y equals mx plus b form, first of all. But also remember, an exponential function has to have an x in the exponent. Okay? Okay, so I put 3 raised to the x power in my calculator, and I'm just going to look at the table. Second graph. Okay, and if you look at my table, I'm trying to make it a little in focus. You look, when x is 3, that equals 27. So that one isn't going to work. Okay, so basically by process of elimination, I see that the answer is 3, but let's just make sure. So 2 raised to the x power Now, if you have a fancy calculator like this, if you want to get out of the exponent, you just hit the side arrow and it goes down. Okay, plus 3. If you have a different calculator, you are going to have to put your exponent in parentheses and then do the plus 3. Please ask questions if you do not understand that. Okay, so look at the table. Did I not put that in right? Oh, plus 1. Sorry. Plus 1. There we go. Okay, so you see if you scroll down, 3 goes with 9, 4 goes with 17, 6 goes with 65, etc. Okay, so again, this is a multiple choice question. So don't work any harder than you have to. Okay, so again, I just put these in my calculator. We got the answer. All right, so now we're going to look at this from a graph. All right, so from a graph, again, we are going to do when x is equal to 0. And again, this is the y-intercept. I can't fit the whole thing, so y-intercept. Okay, b is still the common ratio. And x is the exponent. All right, so the first thing I'm going to pull out, I see right here. And look on your own paper since it's very hard to see on this, but a is equal to 1. Okay, the next thing I'm going to do is, it is pretty much impossible just to look at a graph and just know what the function is. So we're going to make a table. Okay, so you can clearly see all the points. Remember, when we start getting close to the x-axis on the negative side, you really can't see what those points are. They're probably, and not probably, but they're most definitely, unless you know, they're on clear points. But once they start getting really, really close to 0, they're going to be decimals. You're not going to be able to see that with the naked eye. All right, unless it's clearly like 1/2. Okay, so I'm just going to do the ones that are nice and easy. So I see 1, 3, and 2, 9. Okay, so again, this is my a value. They're going up by 1 on the x's, and these are being multiplied by 3. Notice that this says g of x. Okay, so g of x is equal to 1, and then 3 raised to the x power. Easy as that. Okay, next one. So this one, they didn't draw any of the coordinates, so we can do that ourselves.
Miss Amorosi, Andrea Amorosi, if you're in the building, could you please contact the main office? Thank you.
Oh, people must be out today. All right. So this one, again, I cannot really, with the naked eye, see what that is, so we're going to have to use our graph to figure that out, and I'll explain that in just a moment. Okay, so we have our x, we have our y. So I see we have the coordinates 2, 1, 3, 2, and 4, 4. Okay, so we are clearly going, we're multiplying by 2. Okay, so think back to when we did our let's see, our linear equations, but remember I told you to find the y-intercept, we're going to extend the graph, okay? So I'm going to extend it upward, so we're going to do 0 and 1. So now I'm going to go backwards, so I'm going to divide by 2. Okay, so this would be 1/2. If you divide that by 2, that would be 1/4. Okay, so A is going to equal 1/4, and b is equal to 2. Okay, so I'm just going to say y equals, because it says equation. Okay, so remember, equation is going to be a y equals, function is f of x, or something like that. Okay, so 1/4 times 2 is x power. All right, and basically, so the description right there. So first I used the graph to find the coordinates. I found the common ratio was 2, and then expanded the table to find the y-intercept is 1/4. All right, so now with a situation, so this one is a little bit trickier. Okay, so if we have a situation, we're going to do kind of similar. Okay, but we kind of have to pull out our important information usually. Okay, so just to remind you, so if b is greater than 1, that's going to be growth. If b is less than 1, it's going to be decay. Okay, so in 1985, there were 285 subscribers. Subscribers, not describers. Okay? The number of subscribers increased 75%. So that's going to be 1 plus 0.75. Okay? The initial value is 285 because that's what they told us. Okay? And then this is our common ratio. Okay? So when I add that, that would be 1.75. That's my common ratio. 1.75. Okay? Oh, that's a terrible 5. Sorry. Okay, so the exponential equation. Again, equation means y equals, not f of x. Okay? So our initial value goes first. We put that percentage right here, and then raised to the x power. Nothing more than that. All right, now with the next one, they've actually already given us an equation, and they want us to figure out what it represents. So let's break that one down a little bit. Okay, so some banks charge a fee on a savings account that are left inactive for an extended period of time. Okay, not important. Okay, we have our equation right here. So just to remind yourselves, a times b raised to the x power. Okay, so they're telling us, so what I can see is that the initial amount, is 5,000. I know this is going to be decay because b is less than 1. Okay, so let's look at this. So 0.98 is the percent of money in the account initially. That is not true. 0.98 is the percent of money in the account after X years. Also not true. Okay, I shouldn't say that's not true, but what is the y-intercept of the equation and what does it represent? Okay, sorry, I should start there. Okay, so remember our y-intercept is A, and that's what the initial amount is. Okay, $5,000 is the amount of money in the account initially. Absolutely. That is the answer. Again, this is the y-intercept, which is A. Okay? And the last one, the function y equals 41 times 0.95 raised to the x power models the difference in minutes between men's and women's finishing times for the Boston Marathon. The number of years since women first officially ran the race in 1972 is represented by x. Does the exponential function represent growth or decay? Okay, so remember, y equals a b raised to the x power. B is less than 1. Okay, so dk, because b is less than 1. Okay, estimate the difference between finishing times in 1990. Okay, so what we're going to do is we are going to, so 1972 is where we start. So we're going to find the difference from 1990 to 1972. So what we're going to do first is we're going to do 1990 minus 1972. That equals 18. Okay, so this is our x. All right, now we're going to just substitute in. So y equals 41 times 0.95 raised to the 18th power. Okay, so if you throw that in your calculator, you will get, and again, put this literally right in your calculator like this. I put parentheses around it, put parentheses. You do your little caret button, and then hit 18. So 16.2857, okay, and that goes on. So approximately 16 minutes. All right, predict the difference between finishing times in 2015. Okay, so same exact thing, 2015 minus 1972. Again, this gives us our x value because our x represents the years since 1972. Okay? I'm just going to do it right over here. Alright, I'm going to try to make that 43 a little bit better. Okay, so that equals 4.5175. So about 5 minutes. Okay, and that is how we model exponential functions.